So this lesson is on intersections of graphs, which is also called solving equations graphically and inequations. But I want to start with a quick quiz first. So this is drawing polynomials that we did on Monday. So give yourselves a few minutes now to try and draw those three. So I'll get you to stop the video and come back and do the solutions. Well, now you would have had a go at doing this, so let's do it together and see if it works for you. So first one has three different roots, three different zeros, if it equals, to make it equal to 0. So that's going to be x equals 2, x equals 1, and x equals minus 4, negative 4. So as a function, as a polynomial, you just stick those on here and draw a shape to fit. So I'm going to have negative 4, 1, and 2. The other thing to consider is the basic shape, because this will end up being x times x times x, so this is an x cubed graph, which the basic shape is like this. It's a positive x cubed, because it is positive. And these are all single roots, so they all cut. So it comes down like this, goes up, goes down, and it looks very unsymmetrical. It should be symmetrical, it should be smooth. That's really bad. I'm going to draw it again. This is part of the problem with putting the roots on first. You're actually better off drawing a smooth curve than then trying to put the x-intercepts on. So it's symmetrical like this. That looks a lot better. And then I'm going to put minus 4 there, and 1 there, and 2 there. So that's a good way to do it. For interest, because it's this, so you sketch it, you should put the y-intercept up here, which is going to be, if you put in 0, so minus 2 times minus 1 times 4. Minus 2 times minus 1 is 2, times 4 is 8. So I'll just stick an 8 in there. And it looks pretty good. Okay, the next one. In fact, I might even rub that one out in a minute, just see how I go. I'll do this one and I'll rub them both out. Number 2, it has a double root at x equals minus 1. So that means it bounces there. So that's the first thing to realise, it bounces it there. And it cuts at x equals 2. And it cuts at x equals 4. So in terms of the graph, it's going to, and it's a power of 1, 2, 3, 4. It's x to the power of 4 graph. And next to the power of 4 graph starts at the top, ends up at the top. Knowing that it has a bounce at minus 1. So let's draw it. Now I'm thinking it's going to cut at 4 and 2 and bounce at 1. So I'm going to do this. Just check that fits. So it cuts at 2, cuts at 4, bounces at minus 1. That does it. And also we can just check the y-intercept, of course, knowing it's going to be positive. 1 times minus 2 times minus 4. It's at 8 again. The y-intercept is always 8 today. Okay, so that's the first two. Being a video, you can check that. I'm going to rub them off and do the last one, which is definitely a bit of a challenge. So, of course, you can play this video at your own time. You're doing this in class now, but your own time is not a problem. All right, a bit of thinking to be done for this last one. So it has a single root here. Now, what does this give us? 3 minus x equals 0 means x equals 3. It cuts at x equals 3. There's a double root at 4, so which means it bounces at 4. We don't know if it's this way or this way, but we know it bounces at 4, touches. And this one is a horizontal void inflection. It flips over. Again, you don't know if it's going that way or that way. So let's, and the basic shape. How many power, what is the degree of this thing? X cubed times x squared, that's x to the power 5 times another one, it's x to the power 6. So this is an x to the power 6 graph. And it's actually, when you expand it, a negative x to the power 6 graph. So a negative x to the power 6 graph, because it's an even power, ends up going the same direction as it starts. So it's sort of like a parabola, but it's got heaps of bumps. So let's just get the right number. Let's see if this is it. So that's a squared, that's cubed, it's power 4, power 5, power 6, that's correct. So if you had potentially it has 6 roots, 1, 2, 3, 4, 5, 6, which it sort of does. It's just that one of them are here, 2 of them are here, and 3 of them are there. So it does have that basic shape, but we've got to fit this to it. All right, so let's get these points on here, and then we'll be able to draw a bit better. So it goes through -1, it flips over at -1, flips over at -1. It touches at 4, which is out here, and it cuts at 3. As we saw earlier, it's a bit hard to draw sometimes by putting them on first. Let's have a go, and it's going to start like that, end up down there. So it starts down here, ends up down here. So it comes up, flips over. So that's the flipping over at -1. It's going to have a y-intercept up there, which we'll check in a minute. It'll cut at 3 and bounce at 4, but have to go down that way. So it looks like it's going to work. So that was 3. We'll check this out. It's going to be 3 times 16 times 1. So 16 times 3 is going to be 30, 48. So it seems to work pretty well. Just checking that plus or minus bit. It's all plus, yes it is. So it does work, that's what it looks like. It's a bit of a hard one. Okay, on to today. So we're looking at intersections of graphs, and not just the drawing of them, but actually looking at them to solve equations. So that's what we're doing, and we're going to work on these questions. But right now I'm going to go over here to our textbook and actually use this to talk about it, because as you can imagine, drawing the graphs using Desmos would work well, but drawing them by hand is just not going to cut it. Okay, so intersections of graphs. And we're just going to go straight into some examples here. So we have sketch y equals x squared and y equals 1 on the same set of axes, and then solve x squared equals 1. So let's go straight to that. So here's y equals x squared, here's x equals 1, pretending it's drawn on Desmos. And you can see that where they equal each other is when the y's equal each other. It's the points of intersection. So it's 1 and -1. So that's the answer, the plus or -1 for the first one. Okay, the next one says sketch a slightly different parabola, x squared minus x, y equals x squared minus x, and y equals 2 on the same axis, and hence solve x squared minus x equals 2. Again, we're going to look at the point of intersection of these and just read them off. So here's y equals x squared minus x. You could draw it on Desmos. Otherwise, you can find the x-intercepts at 0 and 1. And then there's y equals 2. So these points, the x values, -1, and 2 are the solutions. -1 and 2 are the solutions to x squared minus x equals 2. It's basically like the first step of solving them simultaneously. Get the x values. Yeah, they're both equal 2, but that's okay. All right, and then the third one there was solve x squared minus x is less than or equal to 2 graphically. Now, the reason that says extension is that's a quadratic inequality. In other words, we're going to do exactly what we've done before, draw y equals x squared minus x, which is actually that one we've already have, and y equals 2. So let's go and look at that graph, which is the same as this one. So this is y equals x squared minus x, this is y equals 2, and to solve that inequality, you want to look at when the parabola is underneath the line 2. So we've done this before where we make it positive or negative, but now we just want to see when it's underneath this line. And it's underneath this line here. So what x values does this correspond to? -1 to 2. So that's how we write it. -1 is less than or equal to x is less than or equal to 2. Intersecting lines is all tied in with this as well, but we've done it to death. We really have. So this is solving these simultaneously to get the point of intersection. So there's some of those to practice. There's lots of things you could do here, but obviously Margie's going to times the first one by 2 and the second one by 3 to make the y's the same, and then -1 from the other to end up with an equation and win x, and then sub the x back in to get what y is. You don't have to practice that. You should be fine at doing that. The reason I want to mention that especially is because as a part of this, and mentioned in the syllabus, is break-even points. Break-even points have got to do with cost. So that's what this is. This is a scenario about cost. So, and if you when you start to make a profit, you can say that you've reached your break-even point.
So if they sell cables for $2 each, a company, it costs 50 cents to produce each cable, but has fixed costs of $1,500. So the first thing is find the equation for income on X cables per week. So if you're getting $2 per cable, so for X cables, you just go X times 2. So in other words, I equals 2X. Now you need a cost equation as well. That's basically using Y equals MX plus B. So if it goes up 50 cents for every cable you make, you might as well do it in dollars. So you get C equals 0.5X, it's like the gradients, 0.5, plus 1,500 is the Y-intercept. So you end up with those two equations. Then you have to solve them simultaneously to get the break-even point. So you solve them simultaneously, you end up with, just jumping to it, 1,000 cables. So when there's 1,000 cables, you are going to break even. So the break-even point is 1,000 cables and a cost of $2,000. So the income equals the costs at that point. Now, what was the last question here? It said find the profit on 1,450 cables. So the profit is the income minus the costs. So you could do that a couple of ways. This looks like Margie's going to do it by working out the income by subbing in 1,450 to get 2,900. That's the income if you make and sell 1,450 cables. And the cost is $2,225. So you minus one from the other to get 675. The other way you could do it is actually minus them algebraically first, and then sub in. Then you only got to sub in once. That's why I probably would have preferred to do that. So that's what the break-even point is about. It's economics. Also in this section is another look at solving equations that are non-linear, which we did ages ago. So the key to those, of course, is you end up with two answers most often. So if you've got a parabola crossing a straight line, it's either going to have no answers, one answer, or two answers, depending on what the discriminant is, although we're not worrying about the discriminant here. And that's it. So I want you to work on, I was looking over here, question 1, A to D, part 2. So A, B, C, D, just doing part 2. So do that one, do this one, do this one, do this one, just to get a variety. Doing it graphically, using Desmos, use Desmos for those ones. Then go to question 2B, just picking one of them, so I'm picking 2B, 3B, and then you do the even ones after that, 4, 6, 8, 10. So I'll just turn it around so you can see that written as well, because sometimes people don't actually take it in unless they actually see it written. All right, so good luck with that and see you tomorrow morning.